Welcome to Bird's Eye View. I'm Sam Nunes. So today we're going to talk about trees and some of the information that science is starting to learn about trees and how they can communicate with each other. But I think intuitively humans have known this for centuries, for thousands of years. Many indigenous cultures have known that trees can actually talk to each other. So, without further ado, talking trees. Did you know that trees could talk? So trees can communicate with each other through sharing information with each other about what's going on in the environment around them, or sharing resources with each other. And like I said, science is just beginning to learn about this, so this is all pretty exciting information that we're starting to learn, and I love it. I think it's amazing. So what are the trees saying? Let's get into it. We're going to start at the bottom, at the base, with the roots. Now everybody knows that the roots are meant to hold up the tree. They're the foundation that hold the tree in place so that it can grow tall and wide depending on where it's growing. But they also play a role bigger than that as well. They actually also help to support the trees around them. And so you're going to find with all the stuff I'm going to talk about here that it's more important for the tree that the forest and the species survive rather than the individual tree. So they have a lot of mechanisms that are going to help everybody else survive, even if it's at the cost of themselves. But it ensures that life goes on. And also those other trees on the other end are going to be helping that individual tree. So it's a lot of mutualistic action between each individual organism. So in the roots, they can share their resources. The main resource they share is sugar. And the sugar is what's created during photosynthesis. It's created mostly during the summer in their leaves, and then it's stored in the winter in their roots as starch. And that extra starch and those sugars can be passed between the roots to different trees. And this is very evident actually in species like the American beech, who their roots are so connected actually that they actually can grow new trees off of the roots. They do produce seeds, but they can actually, it's called rhizomal growth. And they can grow trees off of the roots. And that makes them very well connected to share. Normally there's one tree that's like the largest one or the original one, and that's considered the mother tree. And the mother tree can share their sugar with the babies to help them survive. And again, if the babies survive and grow into big, strong trees, they're going to have strong roots and be able to actually support the mother as well. So it benefits the mother to donate or to give away some of her sugar that she's created. Now, roots are not the only form of communication that trees have. They also communicate through pheromones. So pheromones are chemical substances that are produced by an organism that are sent through the air that affects the behavior and physiology of another organism within the same species. Mammals actually do this too. It's why we have perfumes and colognes and deodorant. The scent is giving a message. But yeah, trees do this as well. And the benefit of this is that actually, and I'll get into this a little bit later, the root system, the communication there is very slow. So if the message travels through the air, then it can get to the other trees much faster, especially on a windy day. So trees can actually, this is really cool. Trees can actually identify the saliva of the individual insect or animal species that's attacking them and tailor their response to that creature, to that organism. So they're going to produce pheromones. So let's say, for example, an insect starts eating the leaves. They'll recognize that the saliva of that insect, and they'll produce a chemical pheromone that gets sent out by the wind to all of the other trees around. And it says, hey, I'm getting attacked by this beetle. get ready because it's nearby. And so those trees have a little bit extra time to produce chemicals in their leaves that makes their leaves really bitter and unappetizing, so that when the beetle flies over that tree, they're not going to eat those leaves because they taste gross, and then they'll just move on. So it's saving the trees around them. So an example in the New England area, some examples, one is the oak tree. Oak tree is like the largest tree in the forest, pretty recognizable. They flood their leaves with tannins, and this makes their leaves bitter and unappealing. So tannins is actually what's in wine as well, that helps to preserve it. But it makes it very bitter. Actually, they have tannins, they're in the acorns as well. And I've been trying to learn how to make acorn flour, and you have to remove the tannins. And it's an interesting process. It's a little difficult. I messed up the first time, but not because of the tannin removal. I accidentally burnt them, but that's a tangent that we don't need to go down right now. But yeah, so oak leaves can send those pheromones to the other oak trees to have those ones fill their leaves with tannins to make their leaves bitter and unappealing. So willow trees actually do something similar. They flood their leaves with salicylic acid to do the same thing. This makes the leaves taste bitter and unappealing to insects. But actually, it doesn't have the same effect on humans. Salicylic acid was the precursor to aspirin. So it actually relieves pain, fever, and headaches, and humans have used that for many years. So unfortunately, it wasn't a good defense mechanism against humans, but we also weren't killing the trees for it. So the disadvantage of pheromones is that who receives the message, which trees receive the message, is dictated by the direction of the wind. So if you have trees that are upwind of this tree that's being attacked, they're not going to get the message, and they're going to be oblivious to the incoming attack of the animals or the insects that are attacking the tree. But fear not, trees have an amazing solution to this problem. They actually have a symbiotic relationship with fungi in their roots. Now the benefit here is that the fungi can send electrical messages through their system much faster than through a root system. So in roots, an electrical message moves at about 1/3 of an inch per minute, which is just super slow compared to humans. For humans, it's milliseconds, like things are so fast, but it's 1/3 of an inch a minute for roots. So it would take about an hour for a response to fully get through a tree. But that's cut down a lot by the fungi, which makes it 1/3 of an inch a second to spread those messages. And the benefit here as well is that now it's not dictated by the direction of the wind, so all of the surrounding plants can get the message. And at the end of the day, what the fungi gets in return is they get to tap into some of that sugar that the tree has stored. And again, this is a mutualistic symbiotic relationship, so it's not hurting the tree to have the fungi steal this sugar. It's the price they pay to be able to send the messages between each other. So we're just beginning to understand the language of the trees. It's something truly amazing. Their lives are in slow motion, but they're still just so dramatic. And I love it. But yeah, trees have evolved such impressive defense mechanisms to ensure the survival of the species as well as the forest. Thank you for listening.